Scientists discover the moon is shrinking, causing landslides and instability in lunar South Pole. Scientists have recently made a significant discovery. Earth's moon is shrinking, with its circumference reducing by more than 150 feet over the last few 100 million years. Much like a grape drying into a raisin, the moon's core cooling has caused its surface to wrinkle and develop creases. However, unlike the flexible skin of a grape, the moon's surface is brittle, leading to the formation of faults as sections of its crust push against each other. A team of scientists has found evidence that this ongoing shrinkage has caused notable surface warping in the moon's south polar region, including areas designated by NASA for crewed Artemis III landings. The formation of faults due to the moon's shrinkage often accompanies seismic activity such as moonquakes, which could pose risks to future human exploration efforts. In a paper published in the Planetary Science Journal, the team linked a group of faults in the moon's south polar region to one of the most powerful moonquakes recorded by Apollo seismometers over 50 years ago. Using models to simulate surface slope stability, the team discovered that certain areas are particularly susceptible to landslides triggered by seismic activity. Our modeling suggests that shallow moonquakes, capable of producing strong ground shaking in the south polar region, are possible from slip events on existing faults or the formation of new thrust faults, said the study's lead author, Thomas R. Waters, a senior scientist emeritus at the National Air and Space Museum Center for Earth and Planetary Studies. The global distribution of young thrust faults, their potential to be active, and the possibility of forming new thrust faults from ongoing global contraction should be considered when planning the location and stability of permanent outposts on the moon. Shallow moonquakes occur near the moon's surface, just 100 or so miles deep into the crust. Similar to earthquakes, shallow moonquakes result from faults within the moon's interior and can be strong enough to damage buildings, equipment, and other human-made structures. However, unlike earthquakes, which typically last only a few seconds or minutes, shallow moonquakes can endure for hours, even an entire afternoon, such as the magnitude 5 moonquake recorded by the Apollo Passive Seismic Network in the 1970s, which the research team linked to a group of faults detected by the Lunar Reconnaissance Orbiter more recently. According to Nicholas Schmer, a co-author of the paper and an associate professor of geology at the University of Maryland, shallow moonquakes could devastate hypothetical human settlements on the moon. The moon's surface can be likened to dry, loose gravel and dust. Over billions of years, the surface has endured impacts from asteroids and comets, resulting in ejected angular fragments, Schmer explained. As a consequence, the reworked surface material ranges from micron-sized to boulder-sized, all loosely consolidated. Loose sediments make it highly susceptible to shaking and landslides. The researchers are continuing to map the moon and its seismic activity, aiming to identify more hazardous locations for human exploration. NASA's Artemis missions, set to launch their first crewed flight in late 2024, ultimately aim to establish a long-term presence on the moon and learn to live and work on another world through moon-based observatories, outposts, and settlements. As the crewed Artemis mission's launch date approaches, it's crucial to prioritize the safety of our astronauts, equipment, and infrastructure, Schmer emphasized. This work is helping us prepare for what lies ahead on the moon, whether it's engineering structures better equipped to withstand lunar seismic activity or safeguarding individuals from perilous zones.